Let's go through LeetCode 2919, minimal increment operations to make array beautiful. So we'll give integer array nums and integer k. So we can perform the increment operations any times, any numbers of times. Um, so the operations that you choose index I in this from 0 to n minus 1 and increase nums I by 1. So we are trying to find the minimal operations times to make array beautiful. So what is array beautiful is that for this nums, um, for any three elements, its maximal value should be greater or equal to k. Right? So if we find any of the subarrays which has the three elements, will be greater or equal to k. So let's look at the how can we handle this? The things that we can think about is that um, let's look at the index I for these nums. So let's say dpi represent the minimal operations. The minimal operations we need to index I. And if we increase nums I to be greater or equal to k. So in this case, we know if we increase this number to be greater or equal to k, right? And in order that for any three any arrays which is size 3 should have greatest the maximum greater or equal to k, right? Let's look back. That means I minus 1, I minus 2, I minus 3, right? We must have increased any of these three to be greater or equal to k, right? So what we think about is that the DPI will be the minimal of DPI minus 1, DPI minus 2, and DPI minus 3. And it also need to add, make sure this DPI is greater. So we'll have a data, right? That is k minus dp nums I, right? Should also make sure that they should be greater than 0, right? So let's say if we have a equals nums dot length, right? We have dp new so this is long new long time. So let's say dpi will represent if we make nums I greater equal to k, right? That means if we operate on this number, the minimum operations so far, right? So that is if we have DPI minus 1, that means we need to operate on DPI minus 1, right? So in the end, what we need to return is that we have three choices. Either manipulate at dpn minus 1 or dpn minus 2 or dpn minus 3, right? So we need to find the minimum of these three. So we are return math.main dp n minus 2 minus dot main dp n minus 1 and dp n minus, let's say n minus 3, right? N minus 2 and n minus 1. So let's say the size is greater or equal to 3, right? Or if we don't have this condition, if it is true, right, we just have a common case to make the biggest one. Um, so what we do is that we know uh, because we are trying to find the minimum. So what we do is that we need to have a maximum. Fill the value as maximum. Um, if we don't fill this as maximum, should be fine because for every DPI, it will not omit any values, right? So that is we need to have DP0 equals max dot max 0 k minus nums 0. And we have a DP1, DP2, right? Should not less than, should not be a negative number. So if we don't fill the as is maximum level, should be fine because we are going to calculate every number in I equals 3, I smaller than n, plus plus, then we'll say dpi equals mass dot min dp I minus 3 mass dot min dp I minus 2 and dp I minus 1, right? And for this number, we should make sure it will be greater equal to k, right? So this will be how we do for this question, right? dpi minus 1 should be here, not outside. Doing like this, the time complexity will be ON, and the space complexity will be also ON. But we'll say every I will depend on only on the previous four numbers, right? So we can use a constant space to 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 have beta space complexity. So the thing is that we can have four, right? Number four here, and have this one, and the thing is that for every number we mod by four, right? This is one of the options we do. But the thing is that doing like this, the time complexity is better, right? But the thing is that it actually take more time, especially for some of the small numbers. You see, this is 6 milliseconds, I think. Not this solution. Um, this one. So it's not actually take more time. That means that the for small number, the mod take times, right? So what we think about is that instead of instead of use mod, we can use three variables for this. So what we do is that we don't need this kind of um, DP array, right? So we can have, for example, long. Change this to use a variable long dp1 equals 0L, dp2 equals 0L, and dp3 equals 0L, right? So then what we do is that we use a long dp equals mass of the mean uh, dp1 mass of the mean dp2 dp3, and we have max dot max 0 and k minus um nums I, right? The things that for this one we also need for example this will be k minus nums 0, right? And if we want to have from start I equals 3 to n, right? And in the end, we just, the thing is that after we're doing this, we, for example, this one to be -1, right? This -3. In the end, we just return max dot mean. The thing is that after we're doing this, we should update those kind of values, right? So we know this DPI is here, DPI1, DP1, right? DP2 is here, DP3 is here, and this is DP, right? So that means that we should have DP1 equals this number, and DP2 equals this number, DP3 equals this, right? So what we do is that we have an DP3 equals DP, right? But this means that we should reverse DP2 equals DP3, and DP1 equals DP2, right? And in the end, we just return mass mean DP1 mass mean DP2 DP3, right? So and also actually let's see, this kind of number we can set that as 0 initially, and because that will cover the cases. And let's look at if it is 0, right? So those kind of iteration still works. So we don't need to start from I equals 3, right? We can just set this one as 0L. All of that to be 0L. And just for int nums, right? So this is just a minus num. So this will work as well, right? Doing like this, and you'll see the time complexity still O in space will be constant. Python code will be very similar. Let's write a Python code for this, right? So we have Actually, you see for Java code, we don't need this. Let's get one more line. And the Python code should be very similar. We'll have DP1, DP2, and DP3 because they are all, they are all, they are right. So for num in nums, we are going to have DP equals min, DP1, DP2, DP3, plus max 0k minus none, right? And then we'll have dp3 equals dp2, dp2 equals dp1, and dp1 equals this kind of let's say dp1 2 3, right? This is dp. So we'll have dp1 equals dp2, right? dp2 equals dp3, and dp3 equals dp, right? And then return min dp1, dp2, dp3.